So another example of doing the titration there, and this is something that you will see later on this semester during the lab there, we are going to ask you to do a titration lab to determine the concentration of sodium hydroxide, and you will see the molarity at work, first-hand experience when you work in the lab there. So an example of calculation involved in here, okay, if you have 40.9 milliliter of HCl, and you use that to titrate 1.33 gram of sodium hydroxide, what is the molarity of the HCl solution? Well, in order to determine the molarity, we have to know how many moles of the acid we have there. Volume is already given, 40.9 milliliter. You just got to convert that 40.9 milliliter into liters. So we need to figure out the number of moles of the acid. Well, how do we figure out the number of moles of acid? Well, there's a chemical reaction going on between the acid and base here. Here, sodium hydroxide is a base, HCl is an acid, 1-to-1 molar ratio. You end up with sodium chloride, salt, and water. This is what we call an acid-base reaction. Acid is being neutralized by the base there. When you mix equal quantities of acid and base together, you end up with a neutral solution, salt and water. Okay? So we need to figure out the number of moles of acid. It's not directly given, but there is a chemical reaction between acid and base there. And based on the balanced chemical reaction equation, we can see each mole of sodium hydroxide will react with 1 mole of HCl. So if you can determine the number of moles of base, you know the number of moles of acid. How do we determine the number of moles of base? We have 1.33 grams of sodium hydroxide. Each mole of sodium hydroxide, 40 grams. Okay. Each mole of sodium hydroxide is equivalent to 1 mole of HCl. Mole and mole cancels out. What does that leave you? That leaves you with moles of HCl. Moles of HCl divided by the volume of HCl. 40.9 milliliter converted into liter. Or maybe I should plug in that conversion factor. 40.9 times 1 liter over 1,000 milliliter. Milliliter cancels out. That's the result here. Okay. You get the number of moles here. Sodium hydroxide cancels out. Okay, when you cancel out the gram there, a mole of sodium hydroxide cancels out. That's the number of moles of HCl. Number of moles of HCl divided by the volume of the solution give you the molarity. So that's how molarity is tied in with chemical analysis, acid-base titration there. Okay, we need to be able to identify, if we're asking you to determine one of the 3 quantities there, we have to be able to come up with the other 2 quantities in that definition, in that equation there. Okay? The volume is given directly. Number of moles can be figured out based on the balanced chemical reaction equation. This is how you figure it out. Dimensional analysis, nothing new. Every step of the calculation is a dimensional analysis. Okay? So you will be doing a lot more dimensional analysis when we introduce the molarity there. And you have to remember, this is the conversion factor that we introduce. This conversion factor will help us to do many different things there. And if you plug in the number correctly there, and this is the answer, you're supposed to get 0.813 moles per liter. Make sure you punch in the number after class. And I've had people asking me questions about what we have done in class there on the PowerPoints there. And you got to make sure that you, after class there, you go through these PowerPoint slides there. Whenever I don't have detailed solution on the board there, and you need to make sure when I only give you the answer there, you need to make sure that you run through that question, do the calculation on your own, make sure you get the correct answer. If you cannot get this answer, you need to ask me for help. I'll be more than happy to show you how we set up the equation there. Okay, so another type of calculation that we have here, and again, everything ties back with the definition of molarity. Okay, but when we have the definition, once we know the definition, we will be able to do all these different types of calculations. Here's an example. You're doing a titration in the laboratory, okay, and you have potassium hydroxide, KOH, you have citric acid, H2SO4. Mix two together, you end up with water, potassium sulfate, okay, salt and water. Okay. This is the information you get from the experiment. The molarity of the potassium hydroxide is known, 0.150, given to you. When you do the titration there, we know that we used 16.1 milliliter of potassium hydroxide. We measure out 21.5 milliliter of citric acid. The question is asking, what is the molarity for the citric acid? Okay. Now, once again, this is a combination of definition of molarity and stoichiometry. We've got to figure out the molar ratio between the two reactants here. So in order to determine the molarity of this, we have to know the number of moles of citric acid. Number of moles of citric acid is not directly given here. You got to figure it out based on the balanced chemical reaction equation. Okay, so from the definition of molarity for potassium hydroxide, the moles of potassium hydroxide, if you know the molarity, if you know the volume, you can figure out the number of moles of potassium hydroxide. Okay, so for moles of KOH, M equals to mole over volume. That's the definition. Okay, so 0.150 moles per liter, that's capital M, equals to mole over, we used 0.0161 liter. Okay. Now if you multiply these two numbers, liter and liter cancels out, that will give you a number of moles. Okay, so that's the first thing that we need to do. We need to figure out the number of moles of potassium hydroxide, and if you plug in the number there, 0.150 times 0.0161, volume has to be in liter. Okay, that will give you 0.002415 mole of potassium hydroxide. Now that we know the number of moles of potassium hydroxide, we can figure out how many moles of acid is in there. So in this case, we have 0.002415 mole of KOH that we use. For each mole of H2SO4, 2 moles of KOH is required. So if you set up the equation like this, you can see moles of KOH cancels out. That leaves you with moles of H2SO4. And if you have moles of H2SO4 divided by 21.5 milliliter, 0.0215 liter, I will give you the answer. So this particular step, we are doing stoichiometry based on that 2-to-1 ratio, 2-to-1 molar ratio. Okay. If we figure out the number of moles of KOH, by that 2-to-1 ratio, we can determine the number of moles of the base, of the acid in this case. So 0.002415 times 1/2 divided by 2, well, that 1/2 is the conversion factor that we have here. That's why it's very important that you plug in the units and the quantities of the chemicals in there so you can clearly see what cancels out. That 1/2, that comes from the molar ratio